Hello and welcome to Information Systems Cybersecurity 375. Today we're going to introduce an exciting new topic. We're going to talk about cascading style sheets. So I want to remind you about a couple things as we get started. First of all, hopefully by now you have PuTTY set up on your computer and you should be working on Lab 1. Lab 1 involves two parts. There's first a tutorial that walks you through the basics of HTML. But also there's a creative section, and in the creative section you're creating an adventure game. I want you to try to be as creative as possible in putting that section of the project together. I want to see your creativity. I want to see that you can come up with ideas on your own. So give me an exciting storyline. Give me a web page that is attractive and has lots of interesting content. By the way, I encourage you to go online and read about web development, read about HTML5, read about cascading style sheets, and use some of these ideas in your lab. So even if we haven't covered it in class, feel free to use other web technologies to put this together and make it really impressive. I want to see what you can do. I grade that part of the lab, which I call glitter. I grade the glitter sort of subjectively. I look at it and I say, how creative is this? And I have a rubric that I follow that says, okay, here's some really unique and unusual things they did that other students didn't do. And I say, okay, this is really pretty, or this is a really exciting storyline. It's really engaging. And I'm sort of trying to estimate how much time you put into the project. The more time you invest in making the game interesting and exciting and making it look good, the more points you'll get toward glitter. Glitter is usually worth about 1 letter grade, so if you don't do very good on the glitter, as long as you do everything else correct, everything's technically correct, you'll probably still be able to get an A. But it'll be a low A, an A minus or a low A. If you give me really amazing glitter, that's where you can get a higher grade, a 99 or 100 even. Okay. So last week we talked about HTML, and we said HTML is really supposed to be used for storing content and for representing the structure of a web page, the different groups and blocks of information that we're representing. And HTML is great for storing content, but it's ugly. It is really, really ugly. Because HTML is basically just throwing all the content up there, and while it's grouping related content together, it's not putting it into a nice layout, it's not coloring it or giving it nice font, it's really just putting content on the page. And if we were writing a book or something, that might be okay, but modern web pages, we want something more. We want something that looks pretty, that's interactive, that gives the user visual clues to the different features of the website. So we're going to talk about how we can solve that problem. And the original approach to solving this was to modify HTML, to add tags to HTML for presentation. That's where the bold tag and the italic tag come from. So a bold is really a presentation element, right? If we bold some text, we're saying make it look different, make it heavy and dark. If we put something in italics, we're saying slant the letters. Those are presentation elements. The reason that those have stayed in HTML is that they're really convenient to use in markup. It's really easy to put in a bold tag or an italic tag, and it doesn't create a lot of problems. It's a lot harder to do those kinds of things in a separate document. But a lot of things that go into presentation, the layout of the page, the positions of the different pieces of the site, the colors and the fonts, those things don't fit naturally into markup. And they lead to unreadable code. The more of these presentation elements we have in the web page, the harder it is to find the content. Because in between the words of the paragraphs, we have all these extra tags for make this bold or make this red, and it breaks up the flow of the text, makes it hard to understand, and in particular, it makes it hard to modify the page and edit it. So if we need to fix something or change something, it's a lot harder to do that when we have presentation tags embedded in the HTML. It also makes layout harder. Positioning elements on a web page is actually a very difficult task, and HTML is not well designed for this. The only real element that we can use for laying things out on the page is a table. And putting things into a table is a really rigid structure, and it doesn't lend itself well to doing layout of a web page. For example, suppose that I put things into a column, and some things are really wide and other things are not very wide. Well, HTML is going to expand the column to fit the largest thing. And that means that there's going to be all this extra white space over around the smaller thing, and that extra white space isn't going to look very good. So if I want to position things on the web page using tables, what I'm going to have to do is make some of those table cells span multiple columns or multiple rows, or maybe multiple rows and columns, and I'm going to get a big mess. I'm going to get a really hot mess of junk in my web page. Just terrible stuff. So this is bad. Another disadvantage is that when we incorporate the presentation tags into the HTML document, the pages get really long. Because in addition to all the content, we have all this extra stuff for presentation. And usually, if I want to make, say, paragraphs blue, I have to make this paragraph blue, and this paragraph blue, and this paragraph blue. So I'm repeating the style and presentation elements over and over and over in the HTML. This matters a lot more than it might sound like it does. Not only is it more work to duplicate all that effort, but when I'm loading the web page in the web browser, I want to load fast and be responsive. And the longer the web page is, the more information that there is in the page, the more bytes it takes up, the more resources it consumes. It'll take more space on the disk, it'll take more memory in the web browser, and more importantly, it won't render quickly. Because the browser is going to have to parse all these tags and figure out what they mean and where they go and how to lay things out. It's going to take a really long time, and it has to download all of that information, and so there's a delay over the network too. So it consumes network bandwidth, it consumes memory, and it slows things down. This is bad. Today, users expect websites to be very responsive, to be quick, to load fast. In the bad old days, we didn't really care about that because we want to dial up anyway. Who cares if the page takes a few extra seconds to load when it takes 5 minutes to download in the first place? Things have improved. So the underlying problem that causes all of these issues is a violation of an important computer science principle. In computer science, we believe that you ought to separate concerns. What's a concern? Well, it's some aspect of the design of a project. So in this case, the content is one concern. The presentation is another. Later in the course, we'll talk about a third concern, which is the control of the page, how it interacts with the user. So we'll use JavaScript for the control. So a solution to this that separates content from presentation is to use something called a cascading style sheet, or CSS. CSS is one technology for doing this. Recently, some other technologies have been developed that are a little easier to use than CSS. One example is something called SAS, S-A-S-S. There's also LESS, L-E-S-S. You can see that the computer scientists have some fun with these acronyms. I think it's important to learn CSS because it's used in so many places, and it's a lot harder to learn in some ways than these others. If you learn CSS, it's pretty easy to transition to the others. So we're going to focus on CSS, and we're going to learn the new version of CSS, CSS 3, and you should be able to apply what you learn to these other technologies if you need to. Be great glitter for your project. So the key idea behind CSS is what we talked about before. We're going to separate the content and structure from the presentation. The content and structure will be in our HTML document. The presentation elements, the style, the colors, and the fonts, those will be in CSS. And we're also going to design the language to be efficient at doing presentation kinds of things. So in particular, instead of having to say this paragraph is blue and that one is too and that one is too, we're going to allow the user, the web developer, to generate a rule that matches several elements and says style them all the same way. We're also going to design the language, or it has been designed, to be extensible so that it's easy to add new features. So if you want to use CSS in a web page, you have to somehow link your web document, your HTML document, to your CSS document. And the nice thing about this is since they're in separate files, several different HTML and web pages can use the same CSS style sheet and all look the same, have the same look and feel, and be comfortable for the user. So to do that, we have to put something in the head section of the web page. Remember, the web page is divided into a head section and a body section. Content goes in the body. The configuration of the page goes in head. And in this case, what we're going to do is configure the page to load the style sheet. We do that with a link tag. And the link tag has several attributes. There used to be a type attribute that you had to specify, but in HTML5 that goes away. So now you just have to say that this is a style sheet. So there's a rel tag that says this is related to the style sheet. We have to tell it what the file name is, what the URL is for the style sheet, and we do that with an href tag, just like we do with a link or an a tag. And finally, we have to specify which media types the style sheet is supposed to be used for. In this case, we're going to say media equals all. There are several different media types. when you print a web page, you might want it to look differently than how it displays on the screen. So there's a print media type, there's a handheld media type for displaying on mobile devices, and then there's something like a desktop media type that's used on desktop computers. So there's different media types that you can specify. In this case, we're just going to use the all type, which will produce the same presentation on all different forms of media. Another way that you can incorporate CSS, instead of linking a separate file, is to embed it in the web page. Now, we already talked about why that's a bad idea, but sometimes it's convenient to just throw a little bit of style into one element of a page, and you can do that using a style attribute. Almost every element of the web will take a style attribute. So for example, here we can take a paragraph tag, and we can say that its style is this. It should be colored blue, so the text will be blue, and it should use a 12-point font. So here's an example of a style sheet. We have two patterns that we're going to apply. The first pattern applies to A tags, to anchor tags or links. And it says that they should use a 14-point font. The second pattern applies to paragraphs, to P tags, and it says that every paragraph in the document should be colored green and use a 10-point font. So each of these patterns has two parts. The first part is a selector. The selector is a way of telling CSS which elements of the page to apply the style to. So A and P are our selectors. A says, okay, select anchor tags, link tags. P says select paragraphs. And the other part of the pattern is a list of rules. And each of the rules contains two parts. First, there's some sort of property that we want to configure, and then there's a value that we're using to set. We're setting that property to a particular value. So for example, we have a rule that says the font size property should be set to the value 14 points. So there are lots of different selectors that you can use to identify elements on your web page. Here are some of the most common ones. As I showed you in the example, you can use a tag name. So we can use A or P to identify link or paragraph elements. We can use H3 to style the level 3 header elements. We could apply styles to articles or to the nav bar by using the nav and the article tags for our selectors. Another way to select an element to style is to use its attributes. So we can select against the tag name, or we can use the attributes to select a style. And the most common attributes to use are the ID attribute and the class attribute. We're going to talk in a minute about how those are different, but here are some examples. To use the ID attribute, you use the pound symbol. That's Shift-3 on your keyboard. In computer science, we call it a hash. So the hash symbol followed by the value of the ID attribute. So for example, hash main article will match elements that have the ID attribute set to the words main article. Hash toggle button will match elements that have their ID attribute set to toggle button. We can also match against the class attribute. The class selector starts with a dot, a period. And so for example, if I select against dot title, that will match all elements whose class attribute is set to title. I can also say dot citation, and that would be a selector that matches all elements whose class is set to citation. It turns out you can actually combine multiple classes together, and you can say this element is in both of these classes. And I'll show you in a minute how you can select for that. So here's some examples of how we might do this. Suppose I have a paragraph tag, a P tag, and I set its ID attribute to main article. Okay? Using the style from the previous slide, I could select that element, and I could change its color or its font or whether it's centered or not, and also its position and layout on the page. I can also have paragraph tags that I identify using the class attribute. So for example, the second paragraph here has class set to citation. Notice that the third paragraph also has its class attribute set to citation. The difference between an ID attribute and a class attribute is that you can only have one element with a particular ID on a page. In other words, IDs must be unique within a particular web page. So I can't have two paragraphs with the same ID because that violates the standard. However, I can have two paragraphs with the same class attribute because classes are meant to be shared. I can have multiple elements that have the same class value, and I can actually give an element multiple different class values. I can assign it to be part of several different classes. So this is what I just said, actually. An ID attribute has to be globally unique. And it's often used for things like a logo at the top of the page, or for some sort of division of the page where the main content goes. You usually only have one main content window. Maybe it identifies a footer at the bottom of the page. The class attribute is shared by many elements, and so it's useful for things like identifying the author of a blog post. You probably have several blog posts on the same page, and they all probably have a title and an author's name, and maybe a date or an avatar, or both. So you can use the class attribute to identify all the authors on the page and style them the same way, to identify all the avatars on the page and style them the same way, make them the same width and height, put borders around them. So we can do lots of things. We can also say, okay, this is a sidebar, and make all the sidebars look the same. We can also combine multiple classes. So I could have a blog post class that matches all things in a blog post, but I can also have an important class. Maybe some things are more important than others, and I want them to really stand out. And I could have an element that is in both the blog post class and the important class, and all I have to do is say that in the tag, class equals blog post important with a space in between. And I can put the same element in 3 or 4 or even more classes, although that's very rare. Usually you just need 1 or maybe 2. So if you already have an element in your web page, it's very easy to style it. But sometimes we want to apply styles to things that don't fit neatly into one tag. For example, I might have 2 paragraphs that I want to group together. And I might want to style those 2 paragraphs the same way, but not the 3rd paragraph. So in order to do that, HTML provides 2 special tags that are just used for grouping things. The div tag is a block-level grouping element. It groups things together as a block. And what that means is that it inserts a line break before the block and a line break after the block. So they're visually separated from the rest of the page. Another way to group things is using a span tag. A span tag is an inline grouping element. So it doesn't interrupt the flow of the text. It doesn't insert line breaks. It just identifies text within a block that we want to style in a particular way. So you can think of a div tag as being a lot like a paragraph tag. In fact, they're almost indistinguishable. If I remember right, there's one subtle difference between div and p, but for the most part, you can think of div as being a lot like a paragraph tag. The span tag, however, is a lot more like, say, bold or italic. You can say, okay, start a span here and end it here, and we're going to color all the things in between. But it doesn't introduce a visual separation. It doesn't break the lines into multiple parts or into separate paragraphs. In HTML4 and XHTML, div and span were pretty much all you had for doing grouping. And so you use them for everything. But in HTML5, we have a bunch of new tags that are intended to be used for this purpose. So for example, there's a main tag that identifies the main content of your document, and you can style it in a particular way by just using the main selector. There's an article tag for things like blog posts to distinguish between them. There's a sidebar tag to identify related content. We talked about these last week. There's a header and a footer tag, and there's also a section tag that you can use to separate the major sections of your web page. So the purpose of adding all these tags really had nothing to do with the display of the content, except that it groups them in a particular way so that it's easy to apply style sheets to them. So sometimes we write rules in such a way that more than one rule applies to an element. What do I mean by that? Well, suppose that I have a rule that says that all paragraphs should be colored green, and I have another rule that says anything with the ID chapter 1 should be colored blue. What happens if I have a paragraph that also has the ID attribute set to chapter 1? Will it be green or will it be blue? Well, CSS breaks ties like this by using a rule. And the rule says that more specific overrides more general. Let me say that again. Specific overrides general. So the more specific the rule, the more likely it is to apply. The more general the rule, the less likely it is to apply. In other words, the specific rule will override the general rule. So in this case, if I have a paragraph with ID set to chapter 1, the paragraph will be it'll be blue. It'll be blue because blue is in the ID rule, and the ID attribute is more specific than the paragraph tag. We have lots of paragraphs, P, but only one of them can have the chapter 1 ID. So chapter 1 would be blue, but the paragraph with ID chapter 2 would still be green because it's a paragraph, and so it's green. And it doesn't have the chapter 1 ID that would make it blue. We can also create selectors by combining them together. So one way to combine selectors is what's called joining. So for example, if I say P hash chapter 1, I'm taking two selectors, the P selector that selects all paragraphs, and the hash chapter 1 selector that selects elements with the ID chapter 1, and I'm making a new selector that selects only elements that satisfy both criteria. In other words, paragraphs with ID chapter 1. So in this case, the rule says, if I have a paragraph and it has its ID attribute set to chapter 1, make the font a 20-point font. Another way to combine selectors is called nesting. Nesting means that I have a tag and a closing tag, and inside it I have a second element, a second tag. And the way that nesting works is we apply the style to the inner tag only if it's within that outer tag. So for example, I can say P and then a space, hash chapter 2. And this will apply a style rule only to elements that have ID attributes set to chapter 2, but only if they're inside a paragraph. If they're not in a paragraph, then all bets are off, and we're not going to apply the style rule. So in this case, the style rule that we're going to apply is that the text will be aligned so that it's centered in the page. So any paragraph with ID chapter 1 will be 20 points, but any tag with ID chapter 2 will be centered as long as it's inside a paragraph. So here's how that plays out. Suppose that I have this tag. I have a paragraph tag with ID set to chapter 1. Because it matches the first rule, it's going to have a 20-point font. It's a paragraph with ID set to chapter 1, exactly. Now, in the second example, we have a paragraph tag, and inside that paragraph tag, we have an H3 header. And the H3 header has its ID set to chapter 1. However, the first rule doesn't apply. Because the chapter 1 ID goes with the H3 tag, it's not the ID of the paragraph tag. So the rule will not apply. We're not going to put it in the 20-point font. It doesn't match the second rule either, so it's not going to be centered. So no styling will happen. The default style will be applied. In the third example, we have an H3 tag with ID set to chapter 2, and it's inside a paragraph tag. In this case, the text still won't be 20-point font because the paragraph tag doesn't have ID set to chapter 1. However, the H3 element has ID set to chapter 2, and it's inside a paragraph tag. So this text, the word goodbye, will be centered on the page. In the fourth example, we have an article element with ID set to chapter 2, and inside the article we have a paragraph. In this case, the second rule doesn't apply because the paragraph is inside the element with the ID, not the other way around. If the paragraph were on the outside and the article were nested inside it, then we would apply rule 2 and the text would be centered. But that's not the case, so it's not centered. It's also not in a paragraph that has ID set to chapter 1, so we don't give it the 20-point font. In the last example, we have a paragraph with ID set to chapter 1, and nested inside it, we have an H3 tag, a level 3 header tag, with ID set to chapter 2. Since this HTML code meets both criteria, it will be centered and it will appear in a 20-point font. It matches the first rule because it's in a paragraph with ID set to chapter 1. It matches the second rule because it's in an element with ID set to chapter 2 that is inside a paragraph tag. It's nested inside a paragraph element. CSS3 gives us some additional selectors we can use. It gives us the ability to select siblings. Those are two elements that are next to each other in a document. I'm not going to talk about that. You can Google it. One of the things that's useful, though, is to use a child rule. So the child rule applies if the second element is directly nested in the first. So we use a greater than symbol to represent this combination of elements. So here I have a rule that says hash main screen greater than li. And what that will match is an li element. Remember, li is a tag that gives you a list item, but only if it is the child of an element with ID set to main screen. So li has to be nested inside an element with ID set to main screen, but it can't be nested several levels deep. It has to be an immediate descendant, which means it has to be nested at the highest level. So for example, if I had a paragraph with ID set to main screen, and inside that paragraph I had a div, and inside that div I had a list item, this rule won't apply, because the list item is too deep. But if I have a UL tag, an unnumbered list tag, and its ID is set to main screen, and inside that UL tag I have my LI tag, now the rule will apply, and the text will be green. So here's an example. I have a div with ID set to main screen, and inside that div I have a list, an unnumbered list, a UL, and its class is set to nav list. And inside I have an LI tag with the item text item 1. This text will not be colored green because the LI tag is not a direct descendant of the main screen ID element. There's this UL tag in between. However, if I change my style sheet a little bit and replace the LI in the rule with a UL, the UL tag is a direct descendant of the main screen ID element, the div that has ID set to main screen. So now the entire list will be colored green. In particular, the list element will be colored green. CSS rules use what's called inheritance. So if I color an element green, that element will be colored green, and everything inside it will be colored green too. So in this case, the unnumbered list is colored green, and so all the list items within it are colored green. So we've talked a lot about selectors and how we identify which elements to apply a rule to, but we haven't actually talked about the rules. So what kinds of things can you do with CSS? Well, rules have two parts. They have a property and a value. And the property usually describes something like the color or the size or the position, and the value is a possible choice for that property. So some of the important properties are the background color and the actual text color, which is just the color attribute. The border. Elements can have a border around them. The border element is actually interesting. Border rules have three parts. You can set the size or width of the border, you can set the color of the border, and the style of the border. The default style is none, so if you just set the color of the border, it still doesn't show up on the page. It's invisible because the default style is none. You can set the style to some other things like a solid line or a dashed line, and then you can see your border. We can also set aspects of the font, the size, the font family, the weight, and the style. The font style is whether it uses slanted letters or not, italics and oblique. We can also align the text. That means that we can center it, or we can left or right justify it. We can specify the width and height of elements. This is especially important for images, but actually almost every element. We can specify a maximum width for a paragraph so that it wraps if it gets too big. And we can add margins and padding. So most of these property values use units, some kind of unit of measurement. And when we measure sizes, we typically use things like inches or centimeters. And CSS supports the IN unit, which represents inches, or the CM unit, which represents centimeters. So for example, I can have a rule that says the width should be 3.75 inches. I can also have a rule that says the width should be 22 centimeters. Another unit of measurement is called the point. Points are used in professional typesetting and publishing. Newspapers use them. My mom worked as a copy editor for the Aberdeen American News when I was in high school, and so she learned all about these units of measurement. A point is defined to be 1/7200th of an inch. That's 1 over 7,200. So if you have 3,600 points, that's half an inch. So points are usually used to describe font sizes. So if you know, or if you say I have a 12-point font, what you're really saying is that the height of the letters is about 12/7200ths of an inch tall. We also can measure things in pixels. A pixel is one dot in an image or on a computer screen, and so each colored dot that makes up that image is 1 pixel. We can have an image that's 100 pixels wide, and we can use the PX unit to specify widths in pixels. That's sometimes useful, especially when we're looking at like handheld devices and we need to compare the size of an image with the size of a screen. We can also use relative units. So we can specify the width as a percentage of the current container. So maybe the current container is a paragraph. I have an image that's embedded in a paragraph, and I want that image to take up 50% of the width of the paragraph. Or maybe the container is the entire web page, and I want my paragraph to span 80% of the current page. Maybe I'll have some margins on the side. So I can use the percent unit to get relative widths. Some other relative units that I can use are the M and the X. An M, again, comes from desktop publishing. It's the width of the letter M in the current font. And that's really useful when you're doing web forms, because if you need a text form, a text field that's exactly 20 characters long, you can make the width 20M, and that will just fit 20 letters. Actually, because the form itself takes up some space, you might need to make it a little larger, but it gives you kind of a rough estimate of how big to make things. An X is the height of the letter X. By the way, we picked the letters M and X because M is the widest letter, and I'm not sure actually why we pick X. It's not the tallest letter, but I think the baseline is measured using the letter X. So X just fits the baseline. It's about half the height of the tallest letter or something like that. M is widely supported. Most web browsers support it, and it's pretty accurate. If you specify a width in like 40M, it'll look the same in most browsers. The X unit is not as well supported, so I don't recommend that you use it. Another kind of unit that we use is a color. So if we want to set the color of the background or the color of some text, we need to be able to specify that color. It's important for accessibility never to use color as content. What does this mean? Well, many users are colorblind. And if you use colors to indicate distinctions between elements on a page, those users won't be able to navigate your page easily. So you should use color for decoration. You should use color to give visual clues to some users, but never rely on color, because there are lots of colorblind users, and you want to be able to market to them. You want them to be able to navigate your page easily. I imagine that in this class, about a third of you have some form of color blindness, whether you know it or not. The numbers are pretty well studied. So color blindness is important to take into account when you're designing a web page. Make your pages accessible. Let as many people use your page effectively as possible. So how do we get colors? Well, in CSS 2.1, which was the most common form of CSS until very recently, there were 16 color names. Sometimes people say 17 because they count orange. Black, white, gray, purple, blue, red, yellow, green, and then aqua, fuchsia, lime, maroon, navy, olive, silver, and teal. Don't ask me why they added those. They did. I guess it's because they wanted to have dark and bright versions of each color, so that if your background is light, you have a dark color, and if your background is dark, you have a light color to use. But those are the names. And you can use those in pretty much any CSS style sheet, and they'll work great. In CSS 3, which most modern browsers now support, there's a color module that's pretty well supported, and that adds about 150 new names. Not quite 150. There's a total of 147, I think, different color names, counting the ones that were added in CSS 3 as well as the ones from CSS 2.1. They're based on the X11 color library from Unix, which probably doesn't matter to you, but I find historically interesting as a Linux Unix user. This gives you about 150 colors to play with. That's really not very many, because your computer is capable of displaying millions of colors. So if you want to get a slightly different shade of purple or a slightly different shade of red, you can do that by defining your own colors in HTML and CSS. And the way that that works is that we provide functions in CSS. Now, a function is a name followed by some parentheses. Now, in programming, you learned about functions, and you probably used that same kind of notation, a name and some parentheses. Functions in CSS don't behave quite like programming functions. They don't carry out a computation. They're just a notational style. But we use functions to specify user-defined colors. So in this case, there's an RGB function that will convert values from red, green, and blue into hexadecimal code. So why do we use RGB colors, red, green, blue? The reason is that the human eye has 3 cones, 3 nerve cells in the retina that respond to different wavelengths of light. There's a red cone that responds to red light, there's a green cone that responds to green light, and there's a blue cone that responds to blue light. When you see something that's blue, blue light reflecting from that object hits the blue cone in your eye, and it sends a message to the brain that says, I see something blue. When you see something green or something red, the light reflects off that object, hits the appropriately colored cone in your eye that sends an image to the brain that says, I see something green or something red. Colors with wavelengths of light in between red and green, yellows, oranges, and browns, trigger a response in both the red and the green cones. And depending on the shade of the color, it might trigger more of a response from the red cones or more of a response from the green cones. So a yellow color will trigger both cones, and the brain interprets that as yellow. If you shine a green light and a blue light at someone's eyes, that has the psychological appearance of a color we call cyan. It's kind of a blue-green. If you perceive purple, what's happening is that the red and the blue cones are both being stimulated at the same time. That appears as a kind of magenta or a light purple color. So computers take advantage of the fact that the eye is designed this way to simulate lots of different colors. So what they do, they have 3 little LEDs usually, or some other phosphor or color-generating element. And there's one for red, one for green, and one for blue. And we turn them on at different brightnesses to trick the eye into thinking it's seeing different wavelengths of light. We can stimulate the red and the green cones in the eye using just red and green light and trick the eye into thinking it's seeing, for instance, yellow light. So in your CSS documents, if you want to use RGB colors, the way that it works is what I show here in the example. We say color : to change the text color. And then we use the RGB function, RGB and parentheses, and we put 3 numbers between those parentheses, and those numbers are in the range 0 to 255. That's because we use 8-bit integers for this. The first number is the amount of red to stimulate. The second number is the amount of green to stimulate, and the last number is the amount of blue. So the color 200, 200, 255 would be 200 red, 200 green, and 255 blue. This is going to be a very light blue. Because we've put so much red and green in with the blue, it's going to be almost a gray. But since there's a little bit more blue, it's going to be a bluish gray. The RGB code 255250 has lots of red and green, but no blue, so it will look like a bright yellow. If we want a black color, we don't want any light at all. We want it to be dark, so we say 000. You can also specify RGB codes using hexadecimal codes directly. The way that's done is with a little hash symbol and then a hexadecimal number. A hexadecimal is a base 16 number system that computer scientists like to use. If you don't know hex, just use the RGB function. But in this case, the way it works is that we count using first numbers and then the letters A through F. So we would count in hexadecimal 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. A, B, C, D, E, F, and then we would start with 1, 0, 1, 1, 1, 2, all the way up through 1F, and then 2, 0 through 2F, up to FF, which would be our biggest number. That's 255 in hexadecimal. So in this example, FF00FF represents 3 pairs of hexadecimal digits. Each pair is red, green, or blue. So the first pair is red, so we have FF, which is 255, so that's 255 red. That's the most red we can have. We have 00, which of course is 0 for our green, so no green, and FF again for blue. So we have the most red we can have, the most blue we can have, and no green. We're going to get a bright magenta color. HTML and CSS have a kind of unique abbreviation for this. If you see a 3-digit hex code in a color tag, in the style, not a tag, sorry, in a style rule, what happens is that the web browser will automatically double each of those digits into a 2-digit pair. So the tag C90, the color C90, will actually be the color CC9900. I don't know why they do it that way. I've never seen that anywhere else, but in web programming, we have this little 3-digit abbreviation where they double each digit. So CC9900 is a sort of brownish color, not very pleasant looking, but that's what we would get. In computer graphics, in modern computer graphics, we don't usually use RGB anymore. We use RGBA, which adds an alpha channel. Alpha is a Greek letter that's used to represent the amount of transparency. The idea is if you have 2 images, one on top of the other, you can set a transparency level that will tell the computer how much of the first image to blend with the second image. So you can actually see part of the second image through the first one. A level of 0 means that you have something that's invisible, and all you can see is the one behind it. 255 means opaque. Actually, I think this is done with percentages, so that's probably supposed to be 100. That's probably a typo. But an alpha level of 100% means opaque. You can't see the second image at all. A transparency of like 50% would blend them together. It would average them together. So for example, I can have this color, RGBA of 0,255, 0, 50. That's 0 red, 255 green, 0 blue, and 50% alpha. Another approach to specifying color is to abandon the RGB model, which is not very intuitive for many people, and instead use something called hue, saturation, lightness, or HSL. The HSL model is what's used when you have what's called a color wheel, and you've probably seen these in color choosing widgets. Essentially, it's a circle, and the different hues of color are laid out around the circle. So from the center of the circle to the top, we have the reds. And as we move around the circle clockwise, the shades of red change first into shades of green. So they'll become yellow and then green. And then as we continue around the circle, the greens will get bluer and bluer until we have a blue. And then the shades of blue will become redder and redder. We'll go through purple and come back to the top of the circle where we have reds again. So we have these shades laid out in this circle. At the center of the circle, we have colors that are very light. They're gray. They're neutral colors. And the vibrancy of the color gets greater as we go toward the outside of the circle. So at the center of the circle, we have neutral colors. We have vibrant color at the outside of the circle. So we call that vibrancy of color the saturation. The colors are unsaturated in the middle, they're neutral, they're gray. And as we get out toward the outside of the circle, they become more saturated, more colorful. And then the third dimension is lightness. That's how bright the image is. So 0 is black and 100% is white, and somewhere in between we have most other colors. So for example, I can specify a color by saying color colon, and then the HSL function. And I can set the hue using degrees. So it goes from 0 to 360. So 120, for example, would be about a third of the way around the circle, which would put me in the greens. So this is going to be a green. I'm going to give it 100% saturation, so it's going to be a bright, vibrant green. And I'm going to give it 50% lightness, so it's halfway between white and black. It's going to be a dark but bright, vibrant green. You can get a pink by doing an SHL value. Just like we have alpha channels for RGB, we have alpha channels for HSL, so there's the HSLA function. I can give it a hue of 0, which is red. I can give it 30% saturation, which will make it kind of a gray. But since it's red and we're making it grayer, that's going to make it sort of a pink. And finally, I can give it a 90% brightness, which will make it very light, very pink indeed. And I can set the transparency to 50%. So another property that I might set is the font. And there are lots of different aspects of the font that I can set. Probably the most important is the font family. CSS supports 5 different font families. One is a serif font. Serifs are sharp corners on a letter. And originally, in ancient times, writing was done by carving letters into clay tablets with a chisel. And so you would kind of chip out your letters with a chisel, and that left these sharp corners. Well, it turns out those sharp corners make it really easy to read letters and text on a print document. If you're writing with ink or you're printing something, you should use a serif font because it makes the letters easy to distinguish. The letters that have lots of serifs, like T, look very distinct from letters that don't, like an L. So it helps you distinguish things that often look alike, like L and I and the number 1, or O and the number 0. An example of a serif font is the Times font or the Times New Roman font. Another kind of font is a sans serif font. These are fonts that don't have the serifs. They're smooth. These are better for digital media. If you're going to display something on a computer screen, you should use a sans serif font because the serifs can actually get in the way of readability. They blend together on the screen, and since the pixels aren't smooth, the pixels are discrete, not continuous, it can be harder to read a serif font. So sans serif is the way to go on a computer. An example of a sans serif font is Arial. If you're printing code, you probably want your text to line up in nice, neat columns for indentation, and you should use a monospace font. Other fonts have letters that vary in width. So a T might be wider than an E or an N. or an F might be wider than an R or an S. But in a monospace font, all the letters are the same width, and this means that if you type something that's 5 letters long, it'll be the same width no matter what letters you use, what word it is. This is really nice for programming code, for output, for tabular data, lots of things. So Courier is an example of a monospace font. If you want a more decorative font, you have two choices. You can use a cursive font or a fantasy font. These are pretty looking fonts that add style and decoration to your page. Cursive fonts tend to be really scripty and flowery. Fantasy fonts, like Impact, tend to be really dense and dark, and they, like the lights that just went off, they tend to draw emphasis to headers and titles. You can also set the font weight and the font style. You can also set the size of the font. The font weight is whether it's bold or not. There's actually several different ways to do that. So in summary, you should only use HTML for storing content and giving it structure, not for presentation. You should use CSS for presentation. You should use selectors to identify the set of elements to match. And in CSS, the rules assign values to the properties of the elements. I'm sorry that the lights went off here, but good timing because we're done. I'm looking forward to working with you some more this week. Good luck with your lab.